In this recording, we're going to compare three quadratic functions in their factored form. So I'd like you to start out by looking carefully at those three functions, okay? And to your best of your ability, I'd like you to identify the zeros and the vertex. I know it's a little small to see, but each one of those tick marks, each one of those marks is 1. So even if you can't read the number, you can count and figure out what it would be. All right. If you're not sure about the linear factors just yet, you can leave that part blank, but fill out the zeros and the vertex, and then play the recording when you're ready. Okay, so hopefully we're able to make some headway with B, K, and R. Okay, those are the names we give for our functions here. Y equals R of x, K of x, and B of x, so that we can identify them. All right, so for B of x, we know we're speaking about this graph over on the left. Hopefully you identified the zeros, those places where the y value is 0. In other words, what's the x that makes the y value 0? Okay, and there's actually two of them. It's 1 and -3. You can write them in either order. Nothing special about the order. Okay. And then what's the vertex? Well, the vertex is the turning point. All right, so right about there. So if I'm looking at its x, it looks like -1. The y looks like 4. So if that was like, oh, okay, I get it now, and you feel like you could find the vertex and zeros of the other two graphs where you weren't able to before, go ahead and do that and play the recording. Okay, for k of x, we should have had something like this. We still have 1 and -3. Oh, wow, interesting. Another one where it's the exact same zeros. Now the vertex is different though. It should be at -1, -8. And I just realized I had a mistake on this one. I gotta go back and fix that. That should have been a -4. So sorry for that if that was confusing. Cool. Now the last one, R of x, this graph. You have a set of zeros that aren't the exact same. They're at 1. Oh, excuse me, they are 1 and -3. And, well, what's our vertex? It looks like it's -1 and -2. Okay, so cycling back to the linear factors. Well, we saw in our previous video that when we had a linear factor that looked like this, x -3, say, and we set it equal to 0, the x that produced that had to be a +3. Okay, so if I wanted to make this into a linear factor, I have to say what that number minus what equals 0. So I'm going to do something similar to this. I have to say what would be my linear factor so that when I put a -3 in for x, I get a 0. So if -3 is the x, that would mean it's +3. So -3 + 3. And let's think about this one. When I have my other linear factor, it would be x being a 1, so 1 minus 1 is going to give me a 0. So these would be the linear factors for those zeros. And it turns out for those and those zeros, because they're the same. So now we're going to do a little compare and contrast. I'll leave this to you. I want you to note at least like 3 things that you're noticing that are the same, and 3 things at least that are different. Try to go beyond 3. Find as many commonalities and many differences to compare and contrast. Play the recording when you're ready. Okay, so hopefully you found some things. So there's lots of things you could say. I said these things. They're all concave up. That was something we talked about the other day in our Desmos. They have the same zeros, same linear factors, But that didn't make them the same graphs, right? Because they had some other things that were different. They did all have the same axis of symmetry. Do you remember talking about axis of symmetry? So the axis of symmetry for all these graphs is the line x equals 1. Excuse me, negative 1. And that meant all of their vertex x-coordinates are at negative 1. Okay, so what's different? What's not the same about these? There's lots of things you could have said. Maybe you notice that they have different width. That's not a very technical word, but it's a word I think we can understand, right? Some are skinnier and some are wider. So the width, I'll put in quotes, of the graphs. The y-intercepts change. And what else? The y-coordinate of the vertex changes. So I think as we reflect here, we're noticing that you can have graphs that have the same zeros, same linear factors, but have other traits that make them distinct graphs. And in our future lessons, we're going to figure out how we can find out these linear factors if we don't have a graph to be able to find out these zeros. Thanks for watching.